How's it going? MoNaCo here. We are in our second lecture video for our Unit 8 on kinetics and equilibrium now. We're going to talk about collision theory and 6 factors that we can manipulate to change the rate of a chemical reaction. I hope that you have taken the time to do the reading comprehension and question assignment related to kinetics and collision theory from your practice packet. It was kind of a standalone assignment. You didn't really need to watch any of his lectures in order to understand it. So this lecture is based on the ideas from that particular practice packet assignment. So we're going to identify 2 factors in collision theory and 6 factors overall that affect rates of reactions. And rates of reactions are how quick or how slow a reaction happens. And it's all determined by the rate determining step. But that can be changed by these 6 factors. We can start to manipulate how quick or slow a reaction goes. Okay, so let's get into it. What conditions must exist for a chemical reaction to occur? Knowing these conditions, can we then influence the rate of the reaction? So, what has to happen at first before a reaction can even occur? And then, once we understand that, how can we make that reaction go fast or slow? Okay? Collision theory is that thing that we studied in our practice packet. It defines the things that you need to do, the parameters for all chemical reactions. Changing the nature of the reactants, the concentration, the pressure for gases, of course, temperature, surface area, and the addition of a catalyst can influence how a reaction speeds up or slows down, but collision theory defines what makes a reaction actually occur before you can speed it up or slow it down. So let's get into our notes. In our practice pack, we're going to start talking, our lecture notes pack. We are on, looks like page 2 or 3. Okay? So collision theory. That's a theory that's been put forward in order for a reaction to occur. It says reactants, particles, must collide and have the following when they also do. They have to have the right amount of energy, and they have to have the proper alignment, direction, or orientation. For example, if I want these 2 atoms to combine to make a chemical compound, they have to do so in a very, very careful way. They have to collide with the stick properly with the right energy and orientation, and then the other stick and ball has to go in properly on the other side. That was no small feat. It might have been simple for you and I to do with our hands, but we are putting them together with the right amount of energy. If I didn't push enough, the stick wouldn't go into the ball. There you go, analogy. And our alignment and direction and orientation. I can't get it to work this way because those molecules, those atoms, they don't go together in that way. You have to have the right amount of energy and the right alignment, direction, and orientation, primarily. So here's an image that describes that. They got to hit each other, and they got to hit each other properly. Only when particles collide with these 2 conditions are met will there be an effective collision. I got my molecule to form. That was an effective collision. If these particles collided in other ways, we would not have an effective collision. So, only do we have an effective collision if we have the right energy, alignment, direction, or orientation when they come together. Molecule in the pocket. The 6 things that can affect how that happens. So this has to happen in a very orderly manner in order to reaction to occur. But how can we make it go faster or slower are the 6 factors that affect the rate. The first thing we want to cover is the nature of the reactants. First of all, ionic substances react faster than covalent substances because they react slower. Why? Why do ionic things go faster? Well, they're usually smaller in the first place. They have less bonds to break and less steps in order to form. Here we have sodium chloride, which is an ionic compound, and silver nitrate, another ionic compound, reacting together to make sodium nitrate and silver chloride. Silver chloride is a solid, it's a precipitate out of the reaction, but that happens like really, really fast because these parts are small ions and they're easy to move around in a solution. Now covalent things, they're larger. They have more bonds to break, and therefore it takes more steps. For example, CH4 and oxygen, this is methane and oxygen, so this is like gas, like in a butane or a cooking lamp. They react by breaking 4 carbon-hydrogen bonds and 1 oxygen. So you have to break all the bonds on the reactant side of the equation before you can rearrange them to make all the bonds on the product sides. So there's so many more bonds to break. And here, there was no actual bonds to break. It was just ions swapping around. It happens very quickly. So ionic compounds react much faster than covalent compounds because of their nature. And remember, if you got to figure out an ionic, that's a metal plus a non-metal, M plus Nm. And a covalent are two, it's a non-metal plus a non-metal element. So we're talking about the types of elements involved in ionic compounds, metals and non-metals mixed. In covalents, we just have all types of non-metals sharing their electrons. So let's move on to see the other factors. Concentration. Not thinking hard, but actually adding more stuff to our reaction. If I want to make hydrogen molecules and I add more hydrogens, statistically speaking, if we increase the concentration, we're going to increase the reaction rate. Why? Because there's more stuff. The more particles we have in a given space, the less space between the particles, they're squished in closer, the more collisions that are going to happen. And just statistically, if we have more collisions happening, more of them have to be effective. This is going to happen, in that order, more frequently if there's more stuff jumbling around in order to do it. It's just going to happen quicker. Now, pressure is only for gases. Pressure's only for gases. It typically increases the rate of reaction. Because for gases, if I put more pressure on a gas, it's kind of like taking the particles that I have and squeezing them closer together. So increasing pressure decreases the volume, which decreases the space between the particles. So both concentration and pressure are all about making the particles get closer together, so they're more likely to collide with each other, and a collision is the first part of having a reaction occur. You can't react these two particles if they never make contact with each other. And if they make contact with each other in the right orientation and alignment, they'll stick and make a molecule or a reaction. So that's the third system that affects. So let's talk about temperature. Temperature is easy to remember. Temperature increases the rate of reaction. If you heat things up, reactions go faster. Why? Because temperature is about kinetic energy. If my particles are moving faster, statistically says that they're more likely to hit each other with more energy. So when these two particles hit each other, they'll have the, right amount of energy to become stuck together, versus when they hit each other real slow, they bounce off and move away. If they hit each other with a lot of energy, boom, they get stuck and they become products. Now, you decrease the temperature, the opposite is true. It goes slower. It's why a refrigerator works to prevent milk from spoiling. Milk spoils when it gets too hot because the reaction has more collisions between the milk, sugars, and bacteria and stuff, and it just spoils it around. You keep it cold, slows the reaction down. Surface area. Increase the surface area by making pieces smaller. This increases the rate of reaction, and the opposite is true as well. If I want my Alka-Seltzer or my Tylenol to get rid of my headache faster, oh my gosh, there's one quick and easy thing I can do. I can grind up the pill, the medicine, so that my body absorbs it quicker. Why? Increasing surface area exposes more of the particles to the other particles that they need to react with. So if I grind up my Alka-Seltzer before I put it in water, it's going to dissolve really quickly and my body will absorb it much faster. Versus taking the really big horse pill Excedrin migraine, which take 20 to 30 minutes to dissolve in your stomach and go into your body and get rid of your headache. So you can grind up your medicine to get it to act quicker, but that's based on the fact that surface area determines the rate of a chemical reaction. Let's talk about the last criteria, a catalyst. A catalyst is like a tool, okay? And a catalyst is important because it speeds up the reaction without changing the nature of the reactants or the products. So it's kind of like a traffic man or a traffic cop. Imagine pulling up to a four-way intersection and the power's gone out, right? Everybody knows that when you go to a four-way intersection and the lights aren't working, you take turns and the cars just go one at a time. Well, if a policeman arrives on the scene, he's going to go and stand in the middle of the intersection. He's not going to physically touch any cars or anything, but he's going to say, hey, you guys over here stop, and you folks here come on through. He's going to let cars through 10, 15, 20 at a time, depending on where the longest wait line is. So a catalyst speeds up the reaction by providing a shortcut or an alternate way for the reaction to go. It lowers the amount of energy required for the reaction to occur. If you roll up to that four-way stop sign and there's no policeman there stopping you, you're going to get full of energy and all aggravated and, oh gosh, it's my turn, oh no, somebody else went, blah, blah. But the policeman comes in there, he says, no wait, you, shortcut, come on right through here. All the energy level drops and everything becomes organized and the reaction proceeds in a faster way. You're going to get where you're going a lot quicker than if you hadn't had a catalyst to help you get there. So at this point, you should be able to state what collision theory is. Particles got to collide with correct orientation and energy to make a reaction occur. And the 6 factors that influence the rate of reactions. Temperature, nature of reactants, concentration, pressure, surface area, and presence of a catalyst. Practice packet, page 2 through 4, which you could have done independently, and I hope you did. We have a POGL. It's on the collision theory. It's printed on green paper this time around. And we have a kinetics rates prep, 15-question quiz, and a kinetics rate quiz, 10 questions. Okay? So please complete your assignments and earn some credit. Thanks for watching.